Okay, my AP Statistics pumpkins, this is your next fun video on lessons for Unit 1 notes. I know you're totally pumped. Try to calm down. Okay, so as we move through here, we've talked about categorical data and categorical graphs. They're pretty and all, but you can't do much with them. You can answer a few questions about independence and percentages for this group or that group and how does this compare to that. You can do stuff like that, but you can't really talk about them numerically that much. So that leads us to quantitative data. The rest of our Unit 1 focus will be on quantitative data because that's what you see show up on the AP test the most. So we need to discuss a distribution and what it means to us. Why is it important to us? Well, when I talk about the distribution, I'm essentially just talking about the graph of quantitative data. So if I say, hey, look at that distribution over there, it's pretty. I'm talking about the graph of it. I'm talking about something like this down here. Hey, look at that beautiful symmetric distribution. That's what I'm saying. So when we talk about a distribution with quantitative data, we can address some very important values that are occurring within the distribution that we can't talk about with categorical data. And two of those values are spread and center. Those are numerical values that we're going to be discussing. So when you're asked to describe a distribution or discuss a distribution, talk about it, anything like that, you're going to need to address four important issues. You're going to need to talk about the center of that data. Now, when I talk about the center of the data, I'm not talking about the physical center of the graph. I'm talking about a mathematical center, okay? So when I talk about mathematical center, I'm talking about a value, a numerical value like the mean or the median. Those are the two values for center we're going to discuss in Unit 1. So you'll need to address the center of the math, not the center of the picture. As an example, let's look at this skewed right distribution down here. The values or the distributions that are skewed are often the ones that students have trouble with deciding where the center is. Well, I can look at this and I can easily see the center of the graph, right? It's about right there. But that's not the center of the data. The actual center of the data is a numerical value, and it's going to center closer to where the majority of the data are grouped up. So the center is actually closer to there than it is right in the middle of the physical graph. And this will make more sense as we go through our histogram examples. So when we talk about center, we're talking about a mathematical measure. Okay, unusual features. Well, what would an unusual feature be? An unusual feature would be something like an outlier, some piece of data that is completely away from where the majority of the data are gathered up. Now, I want you to look at these pictures down here. This right here, I'm going to use the skewed right example again. This data piece right here is not necessarily an outlier. It is an unusual value given the rest, where the rest of the data are, but it's not really unusual in its placement. If there was a lot of space right here between most of the data and that data piece, if it didn't like kind of continue on the way it does here, then it would be considered unusual. Okay, other things we talk about the shape. Well, what does the shape look like? Well, some options are right down here with these pretty little red distributions that I have here. We've got this first one. It's symmetric. All right, it kind of clumps in the middle and tapers down to the right and the left pretty evenly. Nothing in the real world is beautifully symmetric like that. And then, of course, we have skewed right. That means the majority of your data is clumped over here on the left, and then it tapers down to the right. That's called the tail. And then we've got non-symmetrical bimodal. So this isn't symmetric, but it kind of clumps together. That's why we call it bimodal. And then, of course, we've got uniform. All of my data is just kind of a big chunky block. It doesn't really change as we go out to the higher values and the lower values. It's pretty much uniform, as the name would imply. Skewed left means the majority of my values are to the right and the tail is to the left. And then I've got symmetric bimodal. So these two mounds that we have here are roughly the same. So it's considered symmetrical. So that's what I'm talking about when I'm talking about shape. And then we've got the other S, spread. Okay, well, when you've just got a picture of a graph, about the only thing you can talk about the spread or the only thing you can say about the spread is that, hey, my data is between this number and this number. I mean, that's pretty much all you can say. You can talk about the range of values. That's pretty much about it. So when we discuss or describe a distribution, we are going to talk about these four things. CUSS, C-U-S-S. The reason we use CUSS is because you can remember it. And we're also going to BS, that means be specific. You're going to be as specific as you can. And keep in mind that when you have an example where you've got the picture of the graph already, you're limited in how specific you can be. Now, if you've got the data of the graph, you can go to town. You've got tons of information, tons of things that you can talk about. So as you'll see in the next videos, we'll dive into this and get a lot more specific about these measures for center, spread. We'll talk more about shape. We'll talk more about unusual values. But this is just kind of an overview of how to discuss